All right, I want to just jump in and get started because this is going to be the hardest week that we're working on, and it's going to take all of our brain cells. And now that August has hit, I know that we all are feeling that timeline on summer, like, oh, summer is going, and I want you to get back to your summer as quickly as possible. Naomi and I are actually going to be working on some problems from page 102 after the regular session today. So if you missed last week's section, or if you were having a hard time filling out your page 101 and 102, you can feel free to hang on the tail end. As a reminder of what you need to do to be done with your summer preparation, hopefully you've been turning in your papers week by week. I have those marked over in ThinkWave. By August 17th, which is 2 weeks from today, all of your summer packet work is due. So if you turned in some pages and there were some problems that were wrong, I tell you which problems were the wrong problems, and I expect you to redo those and turn those back in again. So the ideal summer packet is all of the pages turned in with all of the corrections made. The reason why we're making sure you work on the problem until you can figure it out and do it correctly is because this summer preparation is us making sure that we can all jump in the deep end come September, and we're going to be ready to go and we're not going to drown. So if there's any concept that is confusing to you of our review, we really want to work on that over the summer because we're going to hit the ground running, and we're going to start right in. Also, if you want something to do for the rest of August, because this is the last day that we meet, it would be a really good idea if you review those beginning video lessons from Unit 6, where we ended last year. So if you just start at the beginning of Unit 6 and watch those videos, that would help you get into a good headspace. Of course, you can watch any of the videos from any of the units, but the ones that will be most helpful are the ones that were most recent, and we'll jump on in there. I will be sending out information, although you guys are pretty much on board. You all have your licenses. You all understand how the procedure works. I do have a question for you, though. When we start, we will start with our in-person class, which is, I don't know, September 1st or something, whatever that day is. And then the following week is when we will have our first Zoom class, which is on Tuesday. It is set up in the calendar, in the schedule grid, for the online portion of the class to be on Tuesdays from 12:30 to 2:30. So is there anyone that you're like, there is absolutely no way I can make that whole time? I have this other long-standing appointment that's on a Tuesday. Is there anyone that, to your knowledge, is going to have a hard time with that particular Tuesday time slot?
Wait, can you say the time again?
The online part is going to be on Tuesdays. Let me look to make sure I say it right. From 12:30 to 2:30.
I don't know yet, but I think so. I think I'm good.
You think you're good? Okay, excellent. All right, does anybody have any questions from last week that they want to talk about before we hop into page 103 then? No, excellent. Okay. I'm going to go ahead and do my share screen, and we are going to pop over into annotate, find the right page. I'm really proud of you guys for sticking through the summer sessions here. I know it's hard to be thinking about math in the midst of everything else, but you have done a really good job staying on task. Let's see, units 1 through 6. Here we are. This is our notebook that we have been working on. And yep, this is where we are at. So as always, when we are working on, get my toolbar out of the way. when we are working on any kind of a math problem, you always want to start by taking a look at what it is asking you to do. So when you see this word solve, solve and solution come from that same root. So it is basically asking you to find the answer. And when you have an expression like 17 here, where you have only a single variable a, it is asking you to solve for a. So you are supposed to find out what the value of a is that would make this expression a true expression. Okay, Mick, I'm going to have you start by picking the first person. You can pick yourself or you can pick somebody else to get us going on problem 17 here.
Brady.
Brady. Hello, Brady. We have this, oh, wait a minute. Let me get my head. We have this term right here, and we have this term right here, and we have this term right here. And Brady, you will see that this term is written as a fraction, and this term is written as a fraction. It will be mentally helpful for us if we also could turn this term into a fraction. So how would I change 4 into a fraction?
4 over 1.
4 over 1. Are you really quiet or are you just far away from your screen?
Hold on, let me turn it up. Is that better?
That's better, yes. All right, so this is the exact same expression. And now I can see that the mathematical operation that is being requested is addition. There's my plus sign. When you are adding fractions, what is the basic rule that you always need to follow?
You have to make the bottoms the same.
Yes, you have to make the bottoms the same. The official word for bottom is denominator. So we have one denominator that's a 1. We have one denominator that's an a minus 5. And we have another denominator that is an a minus 5. There are 2 different strategies that we could pick to solve this problem. The first strategy would be that we could make 4 have a denominator of a minus 5, and then we could work on it from there. The second strategy, which is the one that we practiced in this unit, and if you are wondering what unit this is from Unit 6, Part B, Lesson 2. So the second strategy would be, because I see that this denominator and this denominator are the same, that I just try to eliminate all of my denominators in one fell swoop. Which strategy would you like to try first? We'll do both of them so you guys can see the difference.
Let's just eliminate the denominators.
Okay, so I'm going to show you the easiest way to do that. Remember, when you are working with expressions and you have this equal sign that separates the left side over here and the right side over here, you can do absolutely anything that you want to do as long as you do the same thing on the left and the right. So if I want to add 5 over here, that's totally fine as long as I add 5 over here. If I want to divide by a negative 27 over here, that's absolutely fine. I just would have to divide by a negative 27 over here. You just have to keep it balanced. So with that in mind, the easiest way to get rid of these a minus 5s would be to multiply both sides by a minus 5. So if I have a minus 5, and then it's got to be times the whole thing, right? Times 4 over 1 plus 8 over a minus 5, and that's a minus 5 over 1. There we go. Equals a over a minus 5. And by the way, when you are working on these and you have expressions that have two terms like this a minus 5, it's always a really good idea to go ahead and put parentheses around your terms. That will help you keep them straight. So I could put parentheses around those as well. And I multiplied on the left over here by a minus 5 over 1. So I got to do the same thing on the right. So I'm going to multiply this times a minus 5 over 1. All right. Brady, what is the next step of what I need to do here?
Multiply it out.
If dance like people and zombies are outside, what does the D stand for?
Distribute.
Distribute. So we're going to have to multiply this part, and then we're going to have to multiply this part right here. So we have a minus 5 over 1 times 4 over 1. What is that part going to equal?
4a minus 20.
Yes, and you just went ahead and totally got rid of the minus 1. How come you could do that?
Because, wait, because we're just trying to get rid of the denominator.
Yeah, and anything divided by 1 is always itself, right?
Correct.
All right, excellent. So I'm just going to make a little more room here because apparently I want to write big today. And I am going to move that 4a minus 20 way over here where we have room, minus 20. And that was our first part of our distribution. So that part is done. Now we need to do the second part, which is this a minus 5 over 1 times 8 over a minus 5. And before you multiply numerators and denominators, can you cross out anything?
Yeah.
What can you cross out?
The a minus 5.
Yeah. Even though we don't know what a is, we know that a minus 5 is the same number on both sides. And whatever that might be, it cancels out. It creates a 1. So what are you left with?
8.
Plus 8. Excellent. Okay, now on the right side here, before you multiply, can you cross out?
Yes, ma'am.
All right, what are we crossing out?
The a minus 5.
Yeah, so we're making another mysterious 1. We don't know what it is, but we know it has a value of 1. And what are you left with?
A.
Okay, now this problem is looking a lot nicer. I'm going to change the color just so we don't get confused. I'm going to rewrite it up here. So we have 4a minus 20 plus 8 equals a. Okay, Brady, you can pass it along to somebody else.
I picked Mick.
Mick, all right. All we have to do is solve for a. What should we do?
Do you like the like terms with 20 and or negative 20 and 8?
Okay, and when I combine these, what is negative 20 plus 8?
Negative 12.
All right. So if I have 4a, you sound like your horse. Is that KOV voice?
I don't know. I feel fine.
Or maybe you just, your voice went lower an octave over the summer. That's possible too. Okay, now what do you do?
Now we should get the 12 on the other side.
How are we going to do that?
By adding 12.
On both sides, right? Okay. So then we have 4a equals a plus 12. Now what do we do?
1 second. Now you times by the reciprocal of 4a.
Well, not yet, because you still have like terms. You have a's over here and a's over here. So got to take care of that like terms on both sides.
Should we get that a on the left side?
How are you going to do that?
Minus a.
Minus a on both sides. All right, now we have 3a equals 12. Okay, now what do you do?
Now you times by the reciprocal.
All right. And which reciprocal? Reciprocal of what?
3, like times by 1 over 3.
Yes, the reciprocal of 3, because you're trying to turn that 3 into a 1. All right. A equals
4.
4. Excellent. So 17 is done. A equals 4. That is the solution. That is the answer for the value of A. Anybody have any questions on 17 before we move to 18? All right. Excellent. Nick, pick somebody else to start us out on 18.
Emma.
Emma. All right. Emma, we have a similar procedure here. This time, all of them are fractions already, so we didn't have to change like the 4 into a fraction. But looking at our denominators, we have this p, we have this p minus 1, and then we have this binomial right here. So when you are doing problems like this, and you have an unfactored binomial, like this one right here, it will help you a lot to go ahead and factor the binomial first. That will help you figure out what you need to do. So what are the factors of p squared minus p?
P
And
P minus 1.
yeah. All right. So I just mentally substituted p squared minus p with p and p minus 1. And the reason why that is so helpful is because we're like, oh, p minus 1, p minus 1. Awesome. So using the method that we used with Brady, where we are just going to try to eliminate the denominators here completely, what is the least common multiple of p and p minus 1?
P.
P times p minus 1. So not the smaller side. Like, what would both of them have in their times table? You have to take the combo of both of them. So this right here, the p times p minus 1 is that least common multiple. So that's what we are going to use. I'm going to get rid of that just because I need a little more room over there. So if we have p times p minus 1, and that's going to be times this whole expression, times 2 over p plus 3 over p minus 1. I can put all that over 1 so that they all look like fractions, times 5 times p minus 1 times p times, oh, I'm running out of room, p minus 1 over 1. There we go. So the part that we are multiplying by is this part. Okay, Emma, what's the next step? What we need to do?
You need to distribute.
We need to distribute. All right. So I'll write it bigger in the white space and then probably erase it because I'm just not having a lot of room. So we have p times p minus 1 over 1 times 2 over p, right? Okay. Can we simplify this before we multiply?
You can scratch out the P on top and then P on the other bottom.
Right. And then if this is a 1 and a 1, we can totally just forget the denominator completely, right? So what is this part going to be when we multiply it?
2P minus 2.
2p minus 2. All right. So I'm going to get rid of that right there. And I'm going to write smaller up here, 2p minus 2. Okay, so that was the first part of our distribution. Now that plus sign just goes straight on down. Now let's do the second part of the distribution. So it's going to be p times p minus 1 over 1 times 3 over p minus 1. Okay, can we simplify?
The p minus 1s.
P minus 1s. And then that's 1 and 1, so that's going to be nothing. We don't even care about that. What are we left with?
3p.
3p. All right, excellent. Okay, now we have to do it to the other side. So we have our equal sign. I'm going to write it down below just because I don't have a lot of room. We have 5 over p times p minus 1 times p times p minus 1 over 1. All right, can we simplify?
The left denominator and the right numerator can just fly out the window.
That p and that p fly out the window. That p minus 1 and that p minus 1 fly out the window. That's a 1, that's a 1. So the denominator flies out the window. What are you left with?
5.
5. Oh, this is looking so much more welcoming than it was when we started. Okay, Emma, pass it along to somebody else.
Dylan.
Dylan, working from right here, what do we do next to solve for p?
Like terms.
Yeah, so which like terms are we collecting?
The p's
The p's.
and
Two
the
p plus
5
three.
and 5p.
All right, so we have 5p minus 2 equals 5. Now what do we do?
We collect like terms again.
So they're not on the same side. What
Yeah.
do we have to get rid of? We're trying to isolate our p over here. What do we have to get rid of next?
So you add 2.
Yes, yeah, we have to get rid of that 2. So we're going to add 2 on both sides. So that's going to be 5p equals 5 plus 2, which equals what? What is 5 plus 2?
7.
Okay, I'm just going to, for the sake of space, make it 7. All right, now what do we do?
You divide by 5.
Divide by 5, or some people like to multiply by 1/5. Either way, you're going to get the same answer. And let me change
7 over 5.
here. Okay, so p equals, what'd you say?
Oh, 7 over 5.
7 over 5. And there we go. We have the answer to 18. Awesome. Okay. Let me just double check. So I'm going to ask you one by one your level of understanding of the problems we just did. 10 is I understand it completely. I have 0 questions. 1 is what's math, and then you can pick a number in between. So Dylan, what's your understanding number?
10.
Sophia?
10.
Jack?
9.
9. Okay, Emma?
10.
Garrett?
8.
What was your number, Garrett?
8.
8. I wasn't sure if you said 8 or 3. Okay, Brady?
9. 9.
Brady, I don't know what that was.
My voice cracked.
What number was it?
9.
9. Okay, Diamond?
8.
8. Nick?
9.
9. And Naomi?
10.
Okay, so for those of you that don't have a 10, what makes these problems a little bit harder is simply the idea of how to apply fractions, because we all know how to use the fractions appropriately, how to apply those same rules when we are talking about expressions that are complex. So when our fractions have variables, when our fractions have polynomials, all of that type stuff. And what I would recommend is like, look at the hot mess of numbers that are up here in 17 and 18, giving yourself space, like white space, and then working consecutively down the problem will be really helpful. So if you find these a little bit more confusing, I would recommend rewriting the problem on a piece of graph paper or on a piece of lined paper, and then just very slowly and methodically go, okay, what is the next step? And if you're not sure what the next step is, mentally think, what if this was a simple fraction? Like, what if it was 4 plus 1/2? How would I add 4 and 1/2? And then that will help you remember what you need to do. Dylan, I need you to pick somebody to start on problem 19 here for us.
Does anybody want to go?
Just pick somebody who hasn't gone yet, because I'm sure they all want to go.
Emma.
Emma's already gone.
Oh.
Somebody who hasn't gone yet.
Sophia.
Sophia. Okay, so for those of you who are interested or want to go back and watch some videos, this particular problem is from Unit 5, Part C, Lesson 3. So this one is that zero principal property of polynomials, which is a hard thing to say. But basically, when we have a polynomial, like right now we have this binomial equal to 0, if we can factor the polynomial, then we can find out the different possible values of x. And sometimes there's more than one value of x that would make this a true expression. So whenever you see something where there's a polynomial on the left and then equal to 0 on the right, you know that the next step is to factor the polynomial. So, Sophia, when you are looking at this binomial here, first thing we always want to do is we want to see if there is a common factor that we can pull out. So when you look at 4x cubed minus 9x, is there something that is common to both of those terms?
2x.
Well, 2 doesn't equal to 9.
Yeah. So just x.
X. All right. So if I pull out the x, what is the other factor then?
X to the second power.
All right. Well, first x times what is that 4x cubed?
4x
Yes.
Okay.
Yeah. So 4x to what power?
The second power.
Right. So x times 4x squared equals 4x cubed. All right. And then that minus goes straight on down. And then x times what equals 9x?
9.
9. All right. So x over here is now a prime factor that can't get factored down at all. But we need to see what we can do with this polynomial, because now we still have another 2-term polynomial, and if it's not factored all the way down, we aren't going to be ready to solve it. We already know that there's nothing that's a common factor to pull out, because you already pulled out the common factor of the x. So we go through our special cases with binomials. And with binomials, the special case that we are looking at is the difference of 2 squares. Because if this is a difference of 2 squares, then we don't have to factor it. We just have to remember the rule. Is this a difference of 2 squares?
Yes.
Yes. So 4, you can take a square root. X, you can take a square root. And 9, you can take a square root. So when each part of it, you could multiply some number by another number and get that number, which is what square root means. It is 2 squares, and that minus sign means it is the difference of 2 squares. So do you remember what the factors are when it's a difference of 2 squares?
Would it be 2x minus 3
And
2x plus 3?
excellent. Yes, it would. So the reason why Sophia knew that really quickly is just that's how it always is. If it is the difference of two squares, it's the square root of each term. So the square root of 4 is 2, the square root of x squared is x, the square root of 9 is 3, and then one of your factors will use subtraction and one of your factors will do addition. And if you needed to check, then you could always remultiply and check it out. 2x times 2x is 4x squared. 2x times 3 is plus 6x. But then negative 3 times 2x is minus 6x. So plus 6x minus 6x equals nothing. That just disappears. And then negative 3 times 3 is negative 9. All right. Now, Sophia, we have 3 factors, all potentially equaling 0. The logic of math tells us that either x is going to equal 0, or 2x minus 3 is going to equal 0, or 2x plus 3 is going to equal 0. This one is already solved. We already know what x is. Solve for x in this one. What do we do?
Add 3 to both sides.
All right. So then we have 2x equals 3. And then what do we do?
Divide by 2 on each side.
Or multiply by 1/2, depending on, or divide by 2. Depending on how you think of it, it's the same thing. Or divide by 2. So then x equals
3 over 2.
3 over 2. So this is a possible solution for x. And then we got one more, which I guess I need to make a little room because again, I'm taking up all my white space. Okay, do the 2x plus 3.
You would subtract 3 from both sides.
2x equals negative 3. And then?
And then divide or multiply by the reciprocal.
All right. And so x will equal?
Negative 3 over 2.
Yes. Okay, so now we have our 3 possible answers for x. If we write those as a solution set, then it's s equals either 0 or 3/2 or negative 3/2, and we close our bracket. And this is the final book answer, how it should look. So when you have answers like that, you should use this solution set right here. And we won't take the time today, but if we substitute any of these values for x back in the original equation, it would always make a true statement. So that's excellent. Okay, anybody have questions on 19 before we move on to 20? All right, Sophia, pick somebody for problem 20 here.
Diamond.
All right, Diamond. This one is actually way back from Unit 2, Part A, Lesson 4. So what we are working with here is this inequality, this less than or equal to. But other than that, this doesn't look that bad because it's an expression that only has a single variable x right there. So if we want to solve for x, let me rewrite it so it's a little bit bigger. What's the first thing that we should do?
Either 1 over 2.
Well, before, so if we're doing the dance like people and zombies are outside, we don't want to deal with the 2 yet, because that's down here as making a 1. What we need to do first is get rid of the 1 because that's making it into a 0. So how would we get rid of that 1?
Minus 1 on both sides.
Yes. All right. So then we have 2x is less than or equal to, all right, what's minus 5 minus 6?
Wait, I thought it was -1 on both sides.
Oh, sorry. I did it myself. Whoops. Yeah, that's supposed to say a -1. Sorry. And now, what's minus 5 minus 1?
-4.
No, it goes the other way. Minus 6. That's why I have the
6.
6 written in there. So think this is left on the number line and that's left on the number line. Left, you add them together, but it still is negative. Okay, now you can take care of the 2. How do we take care of the 2?
1/2 on both sides.
All right, multiply by 1/2 on both sides. So x is less than or equal to what number?
4.
So
-4.
-6 times 1/2. So if I put it both as a fraction, you multiply the numerators and you multiply the denominators. What do you got?
That'll be -6/2.
All right, and then when you simplify this, what's this going to be?
-3.
There we go. All right, so we have our answer, but we want to write it as a solution set. So the solution set is all values of x such that x is less than or equal to -3. We close our bracket, and this is the final answer. That one feels kind of refreshing after the others. We didn't have to do major polynomial factoring or anything, so that's kind of nice. All right, any questions on 20 before we go to 21?
Wait, I was still writing the answer. And wait,
Okay.
thank you.
Diamond, can you pick somebody to work on 21 for us?
Garrett.
Okay, I'm good.
Okay, great. Garrett. All right, so 21 here, we have this expression that has the fractions, and looking at our denominators, they aren't the same. So we're going to have to figure out what is the least common multiple between 4y and 5. And what would that be?
1.
I'm sorry, can you talk a little louder?
1.
No, so multiple is in the times table. So I know we don't know what y is, but if I am trying to figure out something that is going to be a number that can be divided by 4y and also divided by 5, the simplest thing to do is to make it 4y and 5. So you could call it 20y. I know if I multiplied everything by 20y that it would include at least one 4y and one 5. So similar to the procedure that we did up on 17, we are going to multiply this whole expression by 4y and 5. So I'm going to write it over here, 4y times 5, and I'll put it over 1 so it looks like a fraction, times 8y plus 12. And again, just for the ease of not getting confused, I'm going to go ahead and take my 2 terms and put them in parentheses over 4y equals 6/5 times 4y, let me get that 20y out of the way, there we go, times 5/1. All right, Garrett, let's start on the left side over here. Can I do any crossing out before I multiply?
4y.
Yeah, so those are going to cancel out. How about my denominators?
No.
They just are going to become nothing because they're both 1. Anything divided by 1 is itself. So distribute and tell me what to write.
40y
Yes.
and 6 plus 6.
Plus 60, right?
Yep.
Excellent. Okay, now let's do the right side of this equation. Before we multiply
5.
numerators and denominators, yes, that 5 can
And then the
go
1 just disappears.
and the whole denominator can go. See, this is nice. I don't particularly like fractions myself, so
24y.
whenever I can get rid of fractions, I'm happy. All right, now when you multiply, what is it?
24y.
24y. Okay. Garrett, what do we do next?
We can divide 40y and 24y are kind of alike, so we can do 4y.
Well, did you say divide?
Get rid of them.
Oh, so which one are we going to get rid of? The 40y or the 24y?
Well, I was thinking we were just going to try to break down the numbers, get it more.
I can't quite hear you very clearly, Garrett. I think it's me.
Subtract the 40 from the 24y.
Oh, okay. Thank you, Brady. Whenever you have placeholders on both sides, like here, the basic rule is you always subtract the smaller number. So Garrett, which is the smaller number, the 40y or the 24y?
24.
Yes. So I'm going to take away 24y on both sides. There we go. All right. Now, what would I write?
16y plus 60.
Equals what?
0.
Yeah. Okay. Now what's the next step?
Subtract 16 from 60.
Subtract 60. Because we have to get rid of this thing, right?
Yeah.
All right. And then what do we have?
16y equals negative 60.
Okay. Now what do we do?
16.
What about the 16?
5.
Divide by 16 or multiply by 1 over 16, whichever way you like to think of it. Okay, so y equals how do we write negative 60 divided by 16?
Would it be negative 60 over 16?
Yeah, and then we need to simplify that. So what would that equal? I can see that they're both even. So worst case scenario, I can just chop it in half, divide them both by 2.
Yeah. So you get negative 30 over 8.
All right, and they're still both even, so I could chop it in half
15,
again.
negative 15 over 4.
Negative 15 over 4. This one cannot get reduced anymore, so that's the final answer. Let me take just a minute and talk about reducing fractions. So I'm going to open up a new page over here because there are 2 methods that we talk about. There is the Brady method, which is what you just did, and then there is the factoring method. And I want to make sure that you both understand, or you understand both. So the negative 60 over 16, you just take a simple number that you know they both will divide by. So like divided by 2 over 2, and then that equals the negative 30 over 8. And you just take, okay, I'm just going to do something simple that I know. And so it's divided by 2 over 2. And then that is the negative 15 over 4. And in this particular step that you just added one extra step to get to the 15 over 4, because you divided by 2 here, 2 over 2. So actually you were just dividing by a value of 1. And then you did it again over here. What you could have done is you could have taken the negative 60 over 16 and just divided it by 4 over 4 the first time, because that's what the 2 times 2 is. And then that would have been negative 15 over 4. Same answer, but it's likely that maybe you didn't remember right away that both of them had 16, or both of them had 4 as one of their factors, that 4 was the greatest common factor. So the other method of doing it is to do factor trees. So y'all remember how to do factor trees? Garrett, pick somebody else for me, please. Garrett, if you said somebody's name, we didn't hear you because you're muted.
Jack.
Jack, okay. Jack, start a factor tree for 60 for me here. What are
The greatest common factors.
No, just any 2 factors that multiplied together would equal 60. It doesn't matter what they are.
2 and 30.
All right, 2 and 30. 2 is prime, so we're done with that. Give me 2 factors of 30.
2 and 15.
2 and 15. 2 is prime. Give me 2 factors of 15.
3 and 5.
3 and 5, and both of those are prime. So 60 is actually 2 times 2 times 3 times 5. All right, factor 16 for me.
4 and 4.
4 and 4. All right, factor 4 for me.
2 and 2.
2 and 2, and then that's 2 and 2, and those are all prime. So 16 is actually 2 times 2 times 2 times 2. When you see what is common on the factors of both, you see how they both have 2 2's? 2 times 2 is 4, so that's how you could figure out the greatest common factor between the 2 of them is 4. And so that's how you could know, even if you didn't remember the times tables, that if you just divided it by 4 over 4, you would get the answer right away first time. Now, in a problem like this, doing the Brady method versus doing the factoring method, the Brady method is pretty fast. It worked fine. But in some other problems where it's a lot more complicated, the Brady method is going to slow you down. And every time you have to do another step, the chance for making an error of calculation, just a silly mistake, increases. So try using the factoring method down here and try to get used to it, and you probably will thank me later. Brady method works, but in some cases the Brady method is not going to be the best for you. Okay, Jack, you get to pick somebody else.
Dylan.
Dylan, has everybody? I don't think Naomi's gone yet. I don't know if anyone else hasn't, but I think we need to pick Naomi. Naomi, you're here, right?
Yep.
Okay, I'm gonna have Naomi work on this one, and then it'll be even Steven. So when we look at a problem like this one, there could be a tendency to freak out because what is missing in this mathematical expression?
Numbers.
Numbers! Like, what? I thought this was math. Where are the numbers? Don't freak out. All you have to do is think about symbols. So like in literature, we say that something is a symbol. That means it represents something else. Each of these letters actually is a symbol of a number. So if you wanted to mentally change P1 into a 2, you could do that. Or if you wanted to mentally change V1 into a 5, you could do that. We are not going to be able to find out an exact exact answer for, it says we have to solve for P1. We won't find out a numerical answer to this problem. We are only going to find out a symbolic answer to this one. So we're going to find out what in reference to P this would look like. And it's following the exact same rules of fractions that we always follow. It's just in this particular case, we're dealing with symbols instead of actual numbers. So when it says we need to solve for P1, that means P1 is the symbol that we need to isolate. We need to get it completely by itself. So currently, I'll rewrite it so it's a little bit bigger. We have P1 V1 divided by T1 equals P2 V2 divided by T2. Now, when you have problems like this little one is not an exponent. So think of P1 and P2 as totally different, right? They're not two different versions of the same number. They are totally different numbers. And when you see this V1 and this V2, don't think that they have relationship with each other because they are both V's. Think of them as totally different numbers. So, you know, like if you substituted people's faces instead of that, like, you know, Mick times Dylan. Well, P1 is a Mick. P2 over here is Jonathan. Mick and Jonathan are not the same. And the same thing with the T's, even though it says T1 and T2, just think of them as completely 100% different and not related to one another. So, Naomi, when you're thinking about how you're going to get this thing all by itself, it currently has two attachments that are going to have to unattach. What are the two attachments to the P1 right now?
P1 and T1.
Yeah, that's an attachment and that's an attachment. So, which one is going to be easiest to get rid of first?
T1.
Yeah. If something is divided by T1 and we want this T1 to go away, how are we going to get rid of it?
Can you say it again? Sorry.
Yeah. We want this T1 right here to disappear. So if you think of it as 1 over T1, and we just want it to equal 1, because that's how it's going to disappear for us, what would we have to multiply this fraction by to turn 1 over T1 into 1?
Reciprocal. Reciprocal.
Yeah, so T1 over 1, right?
Yeah.
Okay, so we're going to do that to both sides and see what happens. Because remember, if you do something on the left, you have to do it on the right. You can take 50 steps, and that's fine as long as you do the same thing on the left as on the right. So if I put T1 over 1, and I'm going to multiply that by P1 V1 over T1. And then over here, I have P2 V2 over T2. And I'm multiplying that by T1 over 1. Do all the parentheses. Okay. Do this, but before you actually multiply, can you cross some things out?
Both of the T1s.
Yeah, because they make a 1. And then how about the denominators?
Just one, so it's just P1 with V1.
P1, V1. Okay, now looking over here, can you cross anything out before you multiply?
No.
No, that T1 and that T2 are not related, so you can't. So go ahead and multiply the numerators. What do you have?
P2 times V2 times T1 over T2.
Excellent. Okay, now Naomi, our P1 is not alone yet, so what's the next thing we need to get rid of?
V1.
The V1. how are they attached? Are they attached by addition, subtraction, multiplication? Where's my highlighter? Hello. Hold on. My mouse just went wonky.
Yeah.
My mouse just froze completely. So if I end up accidentally knocking you out of Zoom, just jump back on, because I can't draw without my mouse, and my mouse is saying it doesn't want to do something. So I'm going to try to release it, but I think I am going to have to reboot. Yeah, I'm totally stuck. So I am turning my computer off and back on. It will probably take 2 or 3 minutes and then get back on the exact same Zoom call. Consider this a God-ordained break. So go to the bathroom, get a drink, do something else, and be back on within the next 5 minutes, okay? Sorry about that. Okay, I'm back. Who didn't get back on yet? See Jack and Sophia and Garrett and Diamond and Emma. Dylan and Mick should be on their way. So the good news is we have the recording of what we did so far. The bad news is my annotate did not auto-save when I had to force reboot my computer. So all of the notes that we wrote today on our annotate document are not there. So we will pick up where we left off, and it should be just fine. But if you were hoping to go back into annotate and see the remarks, you'll have to look at it on the recording instead of the annotate document. And I'll just try to save it a little more frequently, because who knows why that happened and if it's going to happen again. So where we were at on problem 22 here, go back to get that out of the way. Did Naomi make it back on? We had P1 V1 equals P2 V2 T1 over T2, right? That's where we were at. Naomi, are you here? Emma, is Naomi not here?
I can check, but I don't think so.
Okay, can you take over for her while she's hopping back on? So we need to now get rid of this V1, and we said that it's attached to the P with multiplication. So how do we get rid of it?
Multiply by the reciprocal.
All right. So what is the reciprocal of V1?
Negative V1.
Nope. No, V1 is the same thing as V1 over 1. So if we're going
Oh,
to do the
1 over
reciprocal,
V1.
yes, there we go. 1 over V1. So I'm doing that on both sides, and keep in mind this is a whole expression over there, 1 over V1. So on the left, when I multiply 1 over V1 times P1 V1 over 1, can I cross anything out before I multiply?
V1.
The V1s. And then what do I do with the denominators?
You just scratch it out.
Yep, because it's just 1. So what am I left with on the left side?
P1.
P1. Great. All right. Now, on the right side, can I cross anything out before I multiply?
Can you cross out one of the V2s, or is that
No, because
Okay.
remember V1 and V2, even though they both have a V, you have to think of them as totally separate symbols for different numbers. So the answer is no, you cannot cross those out. Anything else you can cross out?
No.
Nope. So multiply the numerators. What do I have? Emma?
My internet cut out. I didn't hear what you said.
I said go ahead and multiply the numerators. What should I write?
P2, V2, T1.
All right, and then go ahead and multiply the denominators. What do I have?
T2, V1.
V2, V1. And I realize this is like very unsatisfying as an answer because they're like, well, what value is that? I don't know what value that is, but what it tells us is the relationship of P1, whatever P1 might be, to all these other numbers, whatever they might be. It's more of like a symbolic representation. So that is the answer to problem 22. And I'm going to go ahead and take the time to at least save that one so that if my computer crashes again, that one won't be lost. We have one single problem left. And this is a problem that is worthy of a whole page. So we haven't done word problems hardly at all on our summer review. This is a doozy of a word problem. The basic strategy that we do when we are solving word problems is we figure out how many things there are inside of the problem, and then we come up with one sentence that is a truth about each of those things. And then we translate those sentences into mathematical equations, and then we solve the mathematical equations. So this one is going to be a roller coaster ride. All right, I'm going to read it out loud, and then we're going to see if we can find all of the things that are in here. Through years of diligent saving, not just saving his pennies, but diligent saving, Juan has $25,000, which he is going to invest. Juan plans on investing part of the money into an account that pays 5% annually, and the rest, which is the rest of his $25,000, into an account that pays 10% annually. Now, why Juan would not put all of his money into the account that pays 10% interest instead of 5% interest is a question I cannot answer for you, because logically that makes no sense. Unless maybe the 10% one is not a sure thing, but they don't say that it's risky. Like it says that it will pay. So he's just not very smart that he didn't put all the money in the 10% income, unless he did it only because he knew we needed this math problem. So he is sacrificing his money so that you can learn algebra, in which case you need to say, gracias, Juan. Okay, so two different accounts. One pays 5%, one pays 10%. To supplement his income, Juan wants to earn $2,030 each year. When it says that he wants to earn this amount, this really means he wants this much interest off of his investment. So it's not that he's going to mow another lawn or something like that. It means from his investments, he needs a profit of $2,030 each year. So the question, what is it asking? Let's see, what's a good question? Highlight color, pink, right? How much must he invest into each account to earn exactly $2,030? Okay. Emma, you pick somebody.
Naomi's back, right?
Naomi, are you back?
Yeah.
Okay. So pick one thing that is a piece of information from this word problem.
He puts 5% of his, I mean, wait.
Here, I'll actually give you a hint. There are 8 pieces of information that we can pull out of this word problem. So just give me one of the 8.
He wants to earn at least $2,030 each year.
Okay. So I'm going to underline that we did it. So the interest that he wants is going to be 2030. Okay, Naomi, pick somebody else. And this is like the total interest, right?
Jack.
Okay, Jack, pick out another piece of information. You there, Jack?
Hello?
Yes,
Hello?
hello.
Interest.
Here, I'll even take it from the beginning. Through years of diligent saving, is there anything in those words that we need to remember for our math problem?
Savings.
Yeah, but it doesn't give us any numerical information, so I'm just gonna get that part out. Okay, Juan has 25,000 to invest. Is there an important piece of information from that phrase?
The 25,000.
Yeah, so that's a piece of information. So 25,000 is our investment amount to start anyway. Okay, Jack, pick somebody else.
I choose Sophia.
Sophia? All right, so we are now in this part of our sentence. Juan plans on investing part of the money into an account that pays 5% annually. We'll stop right there. What are the key pieces of information from that part of the sentence?
That he'll get 5% in investments annually.
All right, so 5% and that it's only a part of it, right? It's not the whole 25,000.
Mm-hmm.
So part at 5% return. Okay. And then Sophia, pick somebody else.
Micaiah.
All right, Micaiah, tell us another piece of information. We're starting right here, moving that way.
The 10%.
Yeah. And again, it has this word rest, but this is the other part of the money, right? So one part is going to have 5% return, and a different part is going to have 10% return. So there's our 10%. Okay, then we're done there. All right, we have some questions here that we need to know. Mick, pick somebody else.
Daloon.
All right. Daloon, where does this 2030 come from that he wants to earn? Like where is that money going to come from?
Oh wait, he's just Dylan this year. He's not Dylan anymore.
Oh, really? Okay. Well, good to know. Dylan.
Yeah. I forgot I used to be called Daloon.
That was back in the old days. What is this this $2,030 the combination of?
The combination of the 5% and the 10%.
Yeah. So 5% is one account, 10% is the other account. So if we take whatever number 3 and whatever number 4 are, the value of the investment times the 5%, and the value of the next investment times the 10%, and we add those together, it's going to be that 2030. Excellent. Let me see what is the last piece of information that it gives us. So we have interest earned. We got that one. Oh, the other piece that we didn't add is whatever this part is, that is his first part plus the second part, the total of those all together is that initial amount of the $25,000. Now, typically, I don't write all of the things out as sentences anymore because to me, sometimes it can get a little bit confusing. But what I want to remember is this $25,000 is getting split into two different parts. So Dylan, pick somebody else.
Naomi, I guess.
All right, Naomi, you get to pick what variables we're going to use. So what variable do you want to be for the first part of the money that gets split up?
X.
X. So this is representing the first part of the money, and this is going to be the part that has the 5% return, okay? And then what variable do you want to use for the second one?
Y.
Y. So this is going to be the second part of his $25,000, and this is going to be the part that has the 10% return. Okay, Naomi, pick somebody else.
Diamond.
All right, Diamond. We're going to take this piece of information right here, and we're going to combine it with these variables. So instead of part and part, we're going to use X and Y, and we're going to write an equation that looks like math instead of all these words. What would the equation look like?
X plus Y equals 25,000.
Excellent. Okay. So that is our first mathematical equation. Whatever amount of money part X is added to whatever amount of money part Y is, together they are that investment of $25,000. Great. Now, Diamond, pick somebody else.
Emma.
Emma, let's go back to this information over here. If I want to say how much interest part X earns in a year, I'm going to have to convert this percent into a decimal. So what is the decimal version of 5%?
0.05.
0.05. And then what is the decimal version of 10%?
0.1.
0.1, or if somebody likes it better, they could put 0.10. Either way, it's totally fine. Okay. So Emma, we are going to create our second equation then using the information from this sentence right here and turning it into a mathematical expression. So we know the interest from X and the interest from Y are going to equal $2,030. What would that math expression look like? First off, how do we get the interest from X? What does that look like when we translate it into math?
You cut out. I totally missed like the past 10 seconds.
We need to take the information here and translate the sentence number 1 into a mathematical expression. So we know that the interest from X plus the interest from Y. So the interest from both of the accounts is going to equal this $2,030, but we need to write it as a mathematical expression. So how do I, using math, represent the interest from the X amount of money?
Would you just put X times 0.5?
Yes.
Or the
Yeah. I like
zeros?
to put the coefficient before, but it's the exact same thing. So 0.05x, that's the amount of interest from the X account, plus, and then how do I represent the interest from the Y account?
0.1Y.
0.1y, and how much is that going to equal?
$2,030 also dollars.
Yes. All right. So now we have two expressions with two variables. This is our expression number 1, and this is our expression number 2. We have two ways we can solve, that we know how to solve two expressions with two variables. We can either substitute, or we can add the equations together to eliminate a variable. Emma, which way would you like to try?
Substitute.
Okay. Which equation do you want to work with then? Do you want to work with equation number 1 or equation number 2?
Which one do I want to work with, or which one do I
Yeah.
want to substitute in?
No, which one do you want to work with to isolate the variable? In other words, which one is going to be easiest to work with to create a substitution?
Number 1.
Absolutely. Would you rather solve for X or solve for Y?
What?
Solve for Y?
Yeah.
Okay. So when I keep asking Emma all these questions, would you rather do this or would you rather do this? There is no right answer. You can get the answer to these problems 100 different ways. It's all the choices that you make. So Y equals what?
25,000 minus X.
25,000 minus X. So this is going to be our substitution for Y into this problem now. So if we take problem 2, and Emma, you can pick somebody else now.
Garrett.
All right, plus 0.1, and then instead of Y, I am substituting 25,000 minus X equals 2,030. Now we have a single expression with a single variable. All we have to do is solve for X. So Garrett, tell me what is the first thing that we're going to do to solve our equation number 2 here that we have substituted? That whole dance like people and zombies are outside. So what does the D stand for?
Divide.
Actually, it stands for distribute. So what part do I need to distribute? Where's the parentheses?
The minus X. That's parentheses.
So right here, and then right here, we're going to have to multiply those out and get rid of our parentheses. So we're going to have 0.05x plus, okay, what is 0.1 times 25,000?
That would be 2,500.
Yes, good job. And you knew that because dividing by 10 just moves the decimal point like that. Okay. Minus, and then what is 0.1 times X?
What is this, the x?
I know it still is 0.1x. You can't combine them. They just are multiplied by each other. Equals 2030. All right, what is the next step, Garrett?
Add
What are you going to add?
the point, x and 0.1x.
Yeah, okay. So we have like terms that we can gather together. So we have 0.05x minus 0.1, and I'm going to put the 0 there, x. Okay. When you combine those, what do you get?
Negative 0.05.
Negative 0.05x, because the x still stays, right? Plus, well, wait a minute, that's not right. Because this is 5%. No, that is right. Never mind. You are right. Never mind my never mind. There we go. Okay, now what do we do?
We need to get rid of the 2030.
Do you want to we're trying to isolate the x. So is it better to get rid of the 2500 or the 2030?
2500.
Yeah, and how are we going to get rid of that 2500?
Minus 25. About 20 from each side.
On both sides, right? All right.
The negative 0.05x and 400.
Negative, what did you say it was?
470.
470. Okay. All right. Now what do we do? We're getting somewhere. So far it doesn't look like money at all, but we're getting somewhere.
Get rid of the 0.05.
Yeah, how are we going to get rid of it?
Add 0.05.
Well, the problem is it is currently attached by multiplication here. So when it's attached by multiplication, the only way to get rid of it is to multiply or divide.
Divide it by negative 0.05.
Yes, divide it by itself. Divided by negative 0.05. So that becomes a 1. That's my big 1. So that's just an x. Okay. Now, what is negative 470 divided by 0.05? Garrett, you can continue or you can pick somebody else.
I'll continue.
Okay. So we have to do something before we can actually do this long division problem. What is it that we need to do?
We need to add 2 zeros to each number.
Yeah, so I'm going to move my decimal 2 places, and that means I'm going to have to add 2 zeros. All right, so now it's how many times does 5 go into 47,000? So how many times does 5 go into 4? It doesn't. How many times does 5 go into 47 without going over?
9.
9. And what's 5 times 4?
20.
5 times 4? I mean, sorry, I meant to say 5 times 9.
5 times 9, 45.
45. There we go. Okay. And we subtract. What's 47 minus 45?
2, which would be, take down the 0, which would
Take down the 0. Okay.
be up with 9,400.
9,400. Okay. We know what 9 is. 9,400 is what x is. So we need to go back up and remember, what does x mean? Oh, that's how much money he put into the first part. So, Garrett, now you can pick somebody else. Who'd you pick, Garrett?
Diamond.
All right. So our question up here, the question of the day is how much did he have to invest into each account? We know he started with 25,000. We know that 9,400 went into this account. How do we figure out what is left and what goes onto this side, Diamond?
Do we solve?
Yeah, so we know that X over here is 9,400, right? So I could go back to our equation number 1 and have 9,400 plus Y equals that 25,000. So Y is going to equal 25,000 minus, because I'll get rid of it, 9,400. So the question is, what is 25,000 minus 9,400? And since I totally ran out of white space up there, I'm just going to write it down here. 25,000 minus 9,400. Okay, Diamond. How do we do this? What's 0 minus 0?
0,
And then what's 0 minus 0?
0.
Okay, here we cannot take 4 away from 0. So what do I have to do?
Add a 1.
All right, where did that 1 come from?
Can you cut it out?
So where did that 1 come from that I added?
The 5.
Right, so that's now
So you
4.
cross out the 5, 4.
Okay, and what's 10 minus 4?
6.
Okay, now I cannot take 9 away from 4, so what do I do?
That'll be 14 and cross out 2 with 1.
All right, what's 14 minus 9?
5.
And then what's 1 minus 0?
Is 1.
1. Here is our second amount, $15,600. So the question that we were supposed to solve was how much must he invest into each account? This is the amount for account number 1. This is the amount for account number 2. And that's how he will get exactly $2,030. But again, honestly, why didn't he just put all the money into the account with 10% return? That would be so much smarter. Do you guys have questions on problem 23, this word problem? Okay, I want an honest answer. If we had not gone through this together and you were just looking at the problem on your own, on a scale of 1 to 10, how confident are you that you think you would have gotten to the right answer? Mick, what's your number?
Like 7.
7. Brady.
Also, I have to go.
Okay, see you later.
Thank you.
Brady, what's your number?
7.
7. Okay, Jack?
8.
8. Dylan?
10.
10. Great. Diamond?
5.
5. Yeah, these are harder. Sophia?
Probably like a 5 or 6.
5 or 6. Garrett?
5.
Emma?
Probably like a 9.
And Naomi?
Or like 5.
Okay. So those of you that have the lower numbers, another good thing for you to do would be to go through the book, find the sections that are word problems, and just start practicing working through word problems. Because real life, real application of algebra all is in those word problems. So you can do that. We are officially done with class for today. But if you want to stay on with Naomi and myself and review some problems from last week's pages, page 101 or 102, I don't know which ones Naomi exactly wants to look at, you're welcome to stay on. If not, you can go ahead and turn in your homework assignment of what we did today if you want. I will go into ThinkWave when I'm off the call and open up the assignments. Just make sure that you have everything turned in by the 17th. And make sure you check in ThinkWave, because if you got problems wrong in the comment section, I told you which ones were wrong, and you're going to want to fix those and send those back in. Anybody have any questions? Okay, it's time for you to go if you're going to go, and it's time for you to get out page 100, 102 if you're going to stay. And
Bye.
Naomi,
Thank you.
I need to
Thank
know
you.
what
Thank
problem you want to
you.
start with.